Hello students, welcome back to maths class. So we are dealing with errors and approximations, no? So today we will finish this errors and approximations, right? We are doing the exercise 10A problems, okay? So now come to the question, first question. The diameter of a sphere is measured to be 40 centimeters. Now your diagram is a sphere. In previous problem once we got a cube, right? Once we got a square, right? In yesterday class. Now you got a sphere. So you should know the formulas with respect to square, cube, sphere, all these things, okay? So the diameter of a sphere is measured to be 40 centimeters. So sphere's diameter is given to us. If an error of 0.02 centimeters is made in it, so there is an error in the diameter of the sphere. Then find the error in volume and surface area of sphere. So if you know the formula of volume and surface area of the sphere, then we can easily solve this problem. Okay, so come on, what is the given information to us? Diameter of a sphere is given to us. So come on, first what are the things? Diameter is there and radius we have to take. Why? Our volume and surface formulas are in terms of radius. Sphere, all formulas will be in terms of radius. So come on, let D represents the diameter, R represent a radius, and V is volume, and S, right, represents what? So first radius, right, radius. Second one, first diameter we have taken. So diameter, generally diameter, okay. So then radius, just by seeing the letter you will recognize it, right? Volume, right, volume and surface area, okay, surface area. So what is the given information to us? Given that diameter D is equal to 40 centimeters. What is our radius formula? Radius is equal to diameter by 2. So is equal to 40 by 2 is equal to 20. Okay, so next, error in diameter is given to us. What is that? Error in diameter is given as how much? 0.02. Therefore, error in radius, exactly radius is half, no? So same thing, error also half. Right, 0.02 by 2 is equal to 0.01. Radius is half of the diameter. So error in diameter is this much, means error in radius is half of the error in diameter. Okay, so this is nothing but error in R, means dr or delta R. Okay, so now you take first formula, volume, right? So volume of sphere, right? Volume of sphere is equal to 4 by 3 pi r cube, right? So it is denoted by V is equal to, volume is denoted by, right, V. Okay, so we have to find error in volume. That means only dV we have to find. So differentiating with respect to R, your V function is in terms of R. So differentiate with respect to R. So differentiating with respect to R on both sides. Okay, so come on, it is dV by dr is equal to d by dr of 4 by 3 pi r cube. Okay, so dV by dr is equal to 4 by 3 pi are constants. Let them write outside. So we can differentiate d by dr of r cube, just like d by dx of x to the power of n form, isn't it? So n into x to the power of n minus 1, 3 into r to the power of 3 minus 1, that is 2. So 3 cancel. We want only dv, error in volume means dv value we want. So it is 4 pi r square, sending dr this side, other side. Okay, so dv is equal to, come on, 4 pi into, what is your r? R is, radius is 20, diameter 40 means half of the diameter is radius, half of 40 is 20. So 20 square, okay, into dr, error in radius, right? So error in radius is, it is 0.01, okay, is equal to 4 pi into 20 square, 20 into 20, 400, and we can write 0.01 as 1 by 100, right? So cancels. So 4 4s are 16. So 16 pi. Okay, this is the error in volume. Now you take your surface area. We have to find error in volume as well as error in surface area of the sphere. So come on, you take surface area of sphere. So you should know these formulas. So S is equal to, its formula is 4 pi r square. We want to change error in surface area whenever there is an error in radius. So we can differentiate with respect to r only. S is in terms of r. So we can differentiate with respect to r on both sides, right? So it is ds by dr is equal to d by dr of 4 pi r square. So is equal to 4 pi into d by dr of r square. Okay, so is equal to 4 pi x to the power of n form 2r. We want only ds, isn't it? Error in s is denoted by ds or delta s. Question is find error in volume, error in surface area. So ds is equal to 4 pi into 2r into sending dr that side. So you know all the values, 4 pi 2 into 20, right, into dr 0.01 is equal to 4 pi into how much it is? So 40, right? 2r is, r value is 20, 2r, and this one is 1 by 100. Okay, so this cancel is equal to 16 by 10 pi is equal to 1.6 pi is your error in surface area, rate of change in surface area when there is a rate of change in the radius. If there is a change in radius of a sphere, what are the changes in the volume and surface area of the sphere? That is the question. Okay, if there is an error in the radius of the sphere, what will be the error in volume and surface area of the sphere? Okay, so we got the error in volume is 16 pi and the error in surface area is 1.6 pi. Okay, so now come to the second question, right? So what is the second question? Show that the relative error in the nth power of a number. So you take one value as x and its nth power as another value, That means x to the power of n is equal to y. So relative error of that y is equals to n times of relative error of that number. That means relative error of y is equal to n into relative error of x we have to prove. So you take the number as second question. Let x be the number. Okay, x be the number and its nth power, its nth power is y. Okay, its nth power is y. So we can write implies y is equal to x to the power of n. Its nth power is another number. We have to prove that the relative error in that nth power of a number, nth power of a number means y. So relative error in y is equal to n times the relative error of that number. So we have to prove that relative error in y is equals to n into relative power in x. So relative error in x. So relative error, in a previous class I have given the definitions, right? Absolute error, relative error, percentage error. Delta y is called absolute error, delta y by y is called the relative error, and delta y by y into 100 is called percentage error in y. Here it is given that the relative error of the nth power of the number means y. That means we have to prove that dy by, right, relative error, right, dy by y is equal to n into dx by x we have to prove. So come on, first you take x be the number and its nth power is y. So y is equal to x to the power of n. Take log on both sides. Log y is equal to log of x to the power of n. Okay, so log y is equal to, you know the formula. Which formula? Log a to the power of m is equal to m log a, isn't it? So n into log x. Okay, so differentiating with respect to x on both sides. So come on, d by dx of log y is equal to d by dx of n into log x. Okay, so d by dx of log of any variable is 1 by of that variable into d by dx of that variable. And here n is a constant into d by dx of log x, standard formula is 1 by x. Okay, send dx that side. So dy by dx is equal to n into dx by x. See, we got the answer. What is that? The relative error of the, see, show that the relative error in the nth power of a number is n times the relative error in that number. So we have taken nth power of that number is y. Right, x is one number and its nth power of that number we have taken as y. So relative error of y is equals to n times of relative error of x we have to prove. So that means we have to prove dy by dy by y, right girls, and send this dx to that side. Relative error in y is equals to n times of relative error in x, isn't it? Here send dx that side and write dy by y. That is called relative error in y, which is nothing but what is y? Nth power of that number. So relative error of nth power of that number is equal to n times of relative error of the number. So we have taken x be the number, its nth power of that number is y, right. So relative error in y is equal to n times the relative error in x. We have to prove, we proved it. So very simple, downwards y means if we take a log, you know that d by dx of log of any value is 1 by of that value. So to get that 1 by y or y downwards, we have taken log on both sides, right. So y is equal to x to the power of n, taking log on both sides and applying that formula log a to the power of m, right. So is equal to m log a, so n log x. Okay, now differentiating with respect to x on both sides, right. So here d by dx of log of any variable is 1 by of that variable into d by dx of that variable, and here some constant into log x means constant can be taken outside, and d by dx of log x value is 1 by x. Okay, now send this dx that side. So dy by y is equal to n into dx by x. That is what we have to prove. So the relative error in the nth power of a number is y. So the relative error in y is equal to n times the relative error of that number. That number means we have taken that number as x. Okay, so we have to prove that dy by y is called a relative error in y, dx by x is called a relative error in x. Okay, so hence proved, show that no, so we proved, so you write down hence proved. Okay, so that is the answer. Okay, so observe carefully. Here we have sphere is given to us, previously square is given to us, right. So area of the square asked, volume of the cube asked in previous classes. Now in this class you asked as the formula for volume of the sphere and surface area of the sphere. Both the formulas are with respect to r only. That's why first of all find out what is r and what is dr. So but information is given with respect to diameter. There is an error in the diameter. Diameter is given as 40 centimeters. Half of the diameter is radius. So r is equal to half of 40 means 20. Right. Next, error in diameter is given to you, but we want all formulas are in terms of radius. So we need the error in radius. That's why if error in diameter is 0.02, half of that error will be there in the radius. Y means radius is half of the diameter. So error in radius is half of the error in diameter. You got your dr. dr means change in r or error in r, decrease in r, increase in r. Okay, so error in r, we got this one. After that you take the formula, right. So volume of the sphere, right, 4 by 3 pi r cube. Volume is denoted by V. Question is error in volume, error in surface area. So come on, we want dV. So V is with respect to r. So we can only differentiate with respect to r only. While before doing the differentiation, you have to check the function is whether with respect to x, whether with respect to y, with respect to r, like that we have to check it. Okay, so here your volume is with respect to r, so we can differentiate with respect to r only. Okay, so dV by dr, we want only dV. What is dV? Error in volume. So send the dr to other side, and you know your dr value, that is error in radius. You know your r, radius of the sphere 20. Substitute, you will get it. Similarly, surface area formula is S is equal to 4 pi r square. We want error in surface, ds value we want. That means we have to differentiate S. But How? With respect to what? Observe that S, it is the equation in terms of R. So, we can differentiate only with respect to R. So, then you will get ds by dr, but we want only ds. The error in S we want, we do not want ds by dr. Send that dr to that side. You know dr value, you know r value, substitute. You will get your ds, that means error in surface area. Okay, so be clear with the concepts. Next point, we have to take one number as x and its nth power as another number. That means x to the power of n is equal to y. Then take log on both sides, then differentiate with respect to x. Then we have to prove that the relative error of nth power of the number means y. So, the relative error in y is n times of that number means x, nth power number means y. So, we have to prove that the relative error in y is equal to n into the relative power of x. We got it, right? So, dy by y is called relative error in y and dx by x is called relative error in x. Okay, so be clear with the concepts and formulas, right? Then it will be easy for you. That's all for today. Have a nice day.